Hello everyone, welcome back to the latest lecture session. In the last session we wrapped up water treatment, and while we were wrapping up we were looking at what are going to be the sources of water, let's say, for this burgeoning population. And we looked at what do we say, treated wastewater as being one of the options. So again, you do understand that treated wastewater or wastewater treatment is a remarkably important aspect. First aspect is obviously we looked at dumping of wastes into rivers, and you see how the river is going to be affected. We looked at Streeter-Phelps equation and so on and so forth, and obviously you can do that or apply the mass balance for lakes too, right? And the second option is you want to have water, right, and treated wastewater either for groundwater recharge or for consumption in the lower reaching or the downstream areas is going to be necessary, right. So let us move on and look at the relevant aspects. So wastewater treatment, we are going to look at characteristics and understand some systems, obviously not in detail. So first aspect is the population. So let me look at, let's say, from around independence to 2011. So from 5 to 37 or 40 crores, let's say, right, some 5 crore to 40 crore. And please do note that we were in the midst of wars, famines and such. We been what do we say, we people fought for freedom and got it after, let's say, almost 150 years of what do we say, occupation. And the culture, the habits and such that we had were, or rather that we still have, are not of scientific temper, I guess, right. So again, we had different challenges, and as a developing country we have been meeting them, and we are where we are. So but one aspect is obviously infrastructure, which always needs capital infusion for development, has been lagging behind, and obviously holistic planning too, I guess, right. Again, but keep in mind that we have had different challenges, wars, famines. We were in a place where there were people were hungry, right. People were dying of hunger, and literacy was an issue, right. And again, those challenges have been met. Now we are facing different kinds of challenges, let's see. So again, we see that it's a burgeoning urban population. So urban population as percentage of total increased from 13% to 32 or 31%, right, 13 to 31%. Again, that's in 2011, and I think now in 2020 it will be much more higher. As you can see, it's exponential increase here, right. Okay, let us look at the sewage characteristics, I guess. Again, this is the relevant link, but I think this is again from 2010 or late, what do we say, 2010. So what do we have? Sewage generated is 61,000 MLD, 61,000, or let us say round it off, 62,000 million liters per day, right. And how much are we treating? We are only treating 23,000 liters per day. Again, keep in mind this treatment is typically relatively poor or not good, let us say, right. Again, fine, let us not go into the petty details now, but as you see, a huge percentage is not being treated, and obviously it is wreaking havoc with our what do we say, water systems, let us say, both ground, underground, and subsurface and surface water bodies, let us say, right. So that is what we have. Let us look at the bigger picture once. On the x axis we have million liters per day, and I guess again all this is from government data, I think late 2010 data, I do not have the latest data. So we just played around with it in Excel, and what do we have? We have million liters per day on the x axis, on the y axis different states. So with respect to sewage generation and then installed capacity, let us say, right. Sewage generation, Maharashtra, right, it is generating a lot of sewage. Then Uttar Pradesh, obviously relatively more wealthier population, but again I guess I should have also had the population here, but again, though Uttar Pradesh is the most populous state in India, we see that it is relatively, second highest producer of sewage. But again, keep in mind that the data here is typically sometimes are not always reliable to a great extent, but you can capture the bigger picture. But you can see that greater level of sewage is being treated in Maharashtra compared to Uttar Pradesh, and I guess we see the trends here with respect to Tamil Nadu and West Bengal, almost little to none. Delhi maybe 80% or 70% is being treated, and Gujarat I guess relatively higher. But again the picture is that you see that most of our sewage in those states that we even think of as being relatively more developed, let us say relatively more developed countries, not countries I guess, states, we see that the sewage treatment is pretty low, or sometimes it is abysmal obviously. But again there are different issues, but we just want to get the bigger picture. And if you are looking at the cities, I guess Delhi by far major producer or generator, and I guess sewage treatment capacity, then Bombay and so on and so forth. But Bangalore, I guess I am surprised that it has no sewage treatment capacity, but I am sure this data is erroneous. Maybe the source that I took it from did not get the data in that year. But again the picture is similar. You see that only few cities I guess have higher capacity than their generation, right. Chennai I guess and Hyderabad being the outliers, but the trend is that typically we are generating a lot of waste and treating relatively less. But again this is in the same lines of understanding that more people are moving into the urban areas, but the infrastructure is not able to keep pace with it. We do not have enough employment in the rural areas, so more and more people throng the urban areas where the infrastructure is heaving, let us say, right. So that is what we have out here. And let us say with respect to class 1 cities, let us say water supply, again let us say 2009, and with respect to wastewater being generated, but you see the treatment capacity, let us say, right. Again class 2 MLD cities, first and foremost obviously people will look at water for their survival first. Again we see a quantum jump around 2006 or 95 to 2006, right. And then wastewater what do we say, generation I guess, but treatment again is greatly lagging behind. But now these issues, infrastructure issues, are now coming to bite us in the back pretty severely, let us say. And again government data with respect to households with drainage system and distribution of households by the type of disposal of wastewater, right. So again just overview, one is the rural, and we see that 50% have no drainage, right. And also what do we see with respect to type of disposal of household water, wastewater, we see that 58% let us say is being sent into open lowland areas, let us say, and depending upon the concentration of BOD and COD, the groundwater, the soil and such will be polluted considerably, let us say, right. So that is something to keep in mind. In urban areas what do we see, let us say it is 50% is underground, no drainage, relatively less. But again with respect to type of disposal what do we see, while there is what do we say, drainage system, it is not being disposed onto land and such, I guess it is not clear to me whether it is being treated or not, let us say, right. So that is something to keep in mind. But again keep in mind that we are talking about percentages here, and the concentrations and the volumes here are going to be remarkably high in the urban areas. Again that is something to understand. Why I say this is we see or talk about river cleanups and such, and if you have no drainage in the first case, not drainage systems, let us say drainage collection systems or such, or sewage collection systems, right, say sewerage system is what we call it, and you have all this waste going to the rivers or surface water bodies in multiple what we say channels and such, you can't really treat the river, right. So you have to be able to have a distribution collection system, and then a treatment plant, and then treat this water and discharge it. So now you understand the issues. One is not just the lack of wastewater treatment plants, but more importantly let us say the lack of drainage facilities, let us say, or the sewerage system, right. And let us say typical sewage, I mean this is a picture from our IIT Roorkee's inlet to the STP. STP means sewage treatment plant, STP, and this is what we want to treat it to. I guess from the background this is not from IIT Roorkee, but the one in Haridwar, let us say. We will look at the picture and the pictures from IIT Roorkee later, right. So this is what your treated water looks like. So what is it that we want to do, let us say, we want to prevent this, right. If you dump such organic load, what is going to happen, DO is going to fall big time, and your BOD levels are going to be very high for quite a stretch. You want to you do not want to have this level of ecological death out there, right. So, you have different kinds of waters, right, and what do you want to do? This is from the ghats, which are remarkably polluted. You have dead bodies, flowers, bathing rituals, and so on and so forth. People are trying to make that better, and in some places have made that better. So, what do you want to do? You want to obviously improve the quality of the water out there, right. So, let us see what we have, or typically we are concerned with the Environment Protection Rules of 1986, different amendments and such. So, I guess you can look at the general standards out here. So, what do we have? General standards are given for wastewater generation in part B, load based, general emission standards and noise standards and such. We are concerned with this. There are different standards for BOD, COD, pH, heavy metals and so on and so forth, which we will not look at, but you can, I guess. So, wastewater contaminants, we are not going to look at X, Y, Z and let us say all the 10,000 or 30,000 compounds that we are concerned about, but we are generally concerned about some major aspects or variables, if I may say so. I am concerned about suspended solids. Suspended, as the name indicates, it is not dissolved, it is suspended in the solution, let us say. They can cause sludge deposits, or they can cause deposits and anaerobic conditions in the environment. So, for example, after some time they can settle down, right, and once they settle down, no access to oxygen, let us say in the interior parts or such, and so anaerobic conditions, putrid smells, and again with respect to pathogenic activity and such, right, and again no life typically that is useful to us anyway. And also we also have what is this, biodegradable organics, which we are measuring by BOD, right, biodegradable organics. They can also cause anaerobic conditions in the environment, but biodegradable organics which are present both in suspended solids, but mostly in the dissolved form. What happens, that the microbes can degrade them in the presence of oxygen, thereby decreasing the oxygen levels. So, you do not want to release that, and obviously pathogens from human feces or urine, and they obviously can cause diseases. And as we saw, I think infants 30% deaths due to such waterborne diseases, and nutrients which can cause eutrophication, right. So, hopefully now you understood why we talked about TDS and TSS, BOD, COD, fecal and total coliform, and nitrogen and phosphorus, because in wastewater these are the variables that we are trying to control, let us say, right. Heavy metals, yes, but typically in sewage treatment plants we do not get that. Again, refractory organics and heavy metals, these are typically indicative of industrial activity or wastewater from industries, let us say, right. So, let us move on. Characteristics of domestic wastewater. So, I am concerned with BOD, COD, suspended solids, total dissolved solids, and let us say nitrogen as N, and phosphorus. So, what do we have? Let us say, let us look at the medium value, looks like around 200, COD is 500, but I guess I would say it is a bit off. For domestic water, ratio is typically more biodegradable, TDS around 500, and total dissolved solids TKN, right, measure of nitrogen, let us say 40, and phosphorus 10, which is relatively high out there. Let us look at what it is at the inlet of the sewage treatment plant at IIT Roorkee. This is from 2019 as we see. So, pH again, once before sewerage network, one after that. The issue is that before sewerage network, what happens, wherever it is that you are trying to collect, what does that mean with respect to you did not have a sewage system or sewage collection system, pardon me. So, your rainwater and such comes and mixes, you have dilution, you need to treat a larger volume of water, and also this water can go everywhere out there, right. So, that is why you see that BOD when it was collected before 2016 was low, and when we had a sewerage network, and let us say all the network now brings it to the STP, let us say at the sewage treatment plant, now we see higher and more concentrated value, but the flow would have been, or effective flow will be less, right. So, that is one thing to keep in mind. It is not as if magically the BOD increased. So, 270 milligram per liter BOD, COD, suspended solids, what is this, around 250, TDS we do not have data from this time, nitrogen, right, NH4 and NO3 minus, ammonia and nitrate, and phosphorus, let us say, and fecal coliform, I guess it is at that level, but what do we need to treat it to, right. So, we need to bring it down to less than 10 BOD and less than 50 for COD. For nitrogen, I guess I am not sure why I do not have the data, but okay, for total nitrogen I guess it is 10, and phosphorus, as you see, we have to bring it down to 2, otherwise we are going to lead to eutrophication. And from a high of around 1 lakh, we want to bring the fecal coliform down to 100, let us say, right. So, that is what we have out here. Keep in mind that we want to achieve 10 BOD and 50 COD and around single digits of nitrogen and phosphorus, let us say. And typically though in India, what do we have? We have septic systems which are disposal on site. And why is that? Because we do not have a sewerage network, or when we do not have a centralized wastewater treatment system, obviously on site disposal is required, and septic systems are most common now. But they should be relatively engineered, but they are not done. Typically they are based on passed down knowledge and such. Let us look at a typical system. You are supposed to have your wastewater collected into your septic system, where it is treated anaerobically, obviously, because we are not providing any source of oxygen, as you can see here, right. And then the partially treated water will be distributed out here. But again, in India you do not have the space for this land, let us say, right. And I guess this is let into drainage canals and such, again surface pollution and so on and so forth. You want to distribute it, can be used for what do we say, some kitchen, what do we say, backyards and such, but we do not have the space in India. And with a partially functioning sewage not sewage, septic tanks, we let out polluted wastewater into the environment. So, septic systems, what do you have? Influent, suspended solids settle down, relatively clear water, and then scum layer at the top. What is happening here now? We have settling, some flotation, and more importantly we have anaerobic digestion. You have anaerobic bacteria, right, and the byproducts here obviously are going to be, let us say, methane or the reduced forms of carbon, let us say. And this is the reason when, if you remember, we hear of deaths of what do we say, people still engaged in manual scavenging and such, let us say, right. They go into manholes, and the poor people, literally poor, and because of what do we say, historic issues, they pass away. Why is that? Anaerobic conditions persist in these septic systems, no oxygen is present, let us say, right. And we have, what do we say, little to no, not little, there will be no oxygen present, and you will have other gases which are either toxic, if you have hydrogen sulfide which is toxic, or methane, or other relevant reduced forms of carbon, let us say, right. So, that is why you see people dying when they enter into septic systems without proper breathing apparatus and such, let us say, right. So, let us move on, but typically this is the issue, only 40 to 60% of removal of BOD5 and TSS. For example, T270, so we are letting it out at 135 BOD, which is, as you see, still remarkably high, right. That is something to keep in mind. So, if you have a centralized wastewater treatment plant, what do you do? What are our contaminants of concern? Suspended solids, total suspended solids, and dissolved organics in the form of BOD, COD, nitrogen and phosphorus, and then pathogens, let us say, right. Pathogens, what will you do? Typically you can either disinfect, or as you will see, different process will actually take care of the pathogens. Let us see. So, primary pre-treatment, as in people throw lots of stuff, glass water bottles, plastic and so on and so forth. You want to have pre-treatment to remove them. Bar racks, grit chamber where you remove sand, equalization basin where you hold the wastewater for some time, so that the concentration outlet in the outlet is relatively uniform, let us say, right. Because in the morning you will have a lot of waste coming in the afternoon very little, in the night again more. So, the treatment process out here can't handle that variation, that is why you want to have an equalization basin. So, that is and then, as you know, if the particles are big enough to settle, you can settle them. So, that is why we call them as primary treatment, where typically we are trying to remove the suspended solids. So, when we talk about secondary treatment, we see that we have something called biological treatment, and when we say secondary treatment, we are talking about BOD removal or dissolved organic content removal, let us see. And then when we talk about tertiary treatment, we are talking about nitrogen and phosphorus removal, and sometimes disinfection for pathogens, let us say, right. Primary treatment for suspended, and BOD primarily for what do we say, not BOD, biological treatment for BOD, and tertiary treatment for nitrogen and phosphorus. Obviously, as you increase the level of treatment, the costs also increase. That is why in India typically we have only primary and secondary, and only a small fraction of the plants can remove nitrogen and phosphorus, right. So, I believe we already looked at this, let me not go into that. Primary treatment, it removes 60% of solids, and in that process 35% of the organic content or BOD is also removed. But again, primary aspect, we are trying to remove the TSS. Secondary treatment, here you see that 85% of the BOD and such or BOD and solids is removed, let us say. And again, tertiary treatment, any other remaining organics along with nitrogen and phosphorus and emerging contaminants, but they can't be degraded well though, right. So, that is something to keep in mind. So, what does a picture look like? I believe, not I believe, I should have given the reference for this picture because this was not taken by me. I believe this is from Metcalf and Eddy, if I am not wrong, water and wastewater treatment, or McKenzie et al. I guess. I should have given the reference. Again, what do we have? We have influent wastewater. Here is the office building. Okay, pre-treatment where you remove grit, plastic bottles and so on, not plastic bottles, plastic bottles and so on. Here the water is coming in, and you see large basins for primary treatment, as in you create conditions such that the water will not water, the suspended solids will settle down by gravity, right, and the relatively clear water is going to be sent for secondary treatment out here, right. Secondary treatment, how does that occur, or what do we need to do? So, you can add a oxidizing agent to oxidize this reduced form of carbon, let us say, right, organic carbon, right. You can, or human feces, you can add that, but then it is going to be remarkably costly. So, what can you do? You can let nature do the job, as in microbes degrading the waste. But why will microbes want to do that? Because they also want to thrive, they want to use it for their cell synthesis and metabolic activities and such. But what do you need though? For example, when it is BOD of 270 milligram per liter, and you know dissolved oxygen in water maximum is only 8 milligram per liter or 9, let us say. So, what do you need to do? You need to add oxygen or aerate these what do we say, tanks with oxygen, or aerate it with air which will have oxygen, let us say, because oxygen is the electron acceptor and your waste is the electron donor. And you know this redox what do we say, reaction, let us say, will give out the energy required for the relevant microbes, let us say. And obviously, what do you need? You will also need the microbes, let us say, to let this reaction go faster. And how will they do that? The enzymes that they release will get it done. Again, that is enough out there. And then secondary treatment, and then you know you are going to have secondary settling tanks also, because the microbes, once they oxidize them, they are going to, what do we say, form flocks which can be removed, and then disinfection if you want to, let us say. And as I mentioned, the flocks formed during secondary treatment will settle down, and that is why we say solid management. Otherwise, the sludge, if it is given directly to the farmers, that is going to create its own or the issues, let us say, right. So, that is an overview, and I guess with this I will end today's session, and thank you.